Welcome to qnawire.
All right, we're looking at question 28.70, where we have an infinitely long wire that's bended like this into a corner. And we want to figure out the magnitude and direction that the current produces at this point P over here. So first, just thinking about it, remember that the magnetic field is always going to be a cross product of the direction of the current and then the direction of the vector that's pointing towards the location of the point that we're looking at. That's from the Biot-Savart law. So thinking about this horizontal line up top, the current here is exactly parallel to the vector that would point towards the point P over here. So this horizontal line actually isn't going to contribute anything to the magnetic field at point P. So we can just totally ignore this part of it. Now thinking about this bottom part, we're told that this is an infinitely long wire. It goes down forever. Now this point is exactly at the point at the horizontal location where this wire bends. So if we imagine that there was actually one really long infinite wire that went all the way up here, let me put that like this. If we imagine that there was really an infinitely long wire that went all the way up to the top, then we would know the magnetic field from that. I wrote that over here. The magnetic field from an infinitely long wire can be expressed like this, where r is this absolute distance from the point to the wire. So we have essentially exactly half of that contribution of the magnetic field, because this blue part that I've drawn actually isn't here. This is just if we were to draw a totally infinitely long wire. So if we think about it, since this whole wire is just going to add to the magnitude of the magnetic field here, what we are going to have is essentially just half of the magnetic field from a full infinitely long wire when we consider just this point here. So when we come over here to calculate the magnetic field, all we have to do is just add a 1/2 here, because this is the magnetic field from an infinitely long wire. So if we just cut that in half and say we're only going to consider the bottom half of that, that's going to give us just a contribution of 1/2 here. So I'm going to bring that factor of 2 down to the bottom, multiply that by this 2 here, and that gives us 4. Now thinking about our variables that we have, we're told that the current is just I, and then r, the distance from the wire, is a, so we can just plug that in, and we know everything else, so this is just going to give us the magnitude of the magnetic field at point P here. Now thinking about the direction, we want to use the right-hand rule. Let's think about the current that's causing this magnetic field. It's pointing down. So if we point our thumb in the direction of the current and then curl our fingers around, at this point over here, our fingers are going to be pointing out of the page. So the direction of the magnetic field at this point will be out of the page.